Hello guys, so today we'll be discussing our physics mock test solutions. So already each and every one of you have given this mock test. So I'm pretty sure many of you have gained a lot of confidence in this mock test. And again I'll say, whoever has not done so well, please look upon your mistakes. In this class definitely many things will be much more clarified to you, and you are going to work hard on those part where you have not scored well, and definitely we all will be coming out with very much flying colors, right? So let us start our video solution series of various mock tests conducted at Supnet's classes. So we'll start with the MCQ part over here. So if you see this, the CG of a triangular lamina is centroid. Yes, so this is a pretty easy question. There is nothing much to say about it. So question number 1. So in question number 1, the first question will be, option will be A. So various geometrical figures whose CG is given in the syllabus, you need to remember them, because at this point of time we are not going to find out how to find out the CG of each and every geometrical figures. Rather than we have to remember those center of gravity points. Definitely you are going to find those by various calculations in class 11th. Okay, unit of power. So how will I find out the unit of power? So power is force into displacement, that is work, by time. What is the unit of force? Newton meter by time. Newton meter by second. Newton means m into a, that is mass into acceleration, kg meter per second square into meter by second. So kg meter square second to the power minus 3. So this will be option number D. This will be option number D. Okay. Number 3, unit of moment of force. Unit of moment of force will be Newton meter. You cannot write this as joule or arg. Please remember this. There is difference between Newton into meter in case of moment of force, and in case of work done, yes, you will write joule. Those are different types of vector products which you will learn in higher classes, but at this point of time it is very well written in your textbook that in case of moment of force, when it is written as Newton meter, you cannot write it as joule. This statement is given in your textbook. Number 4, mechanical advantage. Number 4, mechanical advantage of single movable pulley with friction. Okay, see, normally single movable pulley has mechanical advantage of 2. However, with friction it will be between 1 and 2. So this will be option C. This will be option C. Number 5, which property of the wave doesn't change when it passes from one medium to another? Very easy question. Frequency. Option A. Number 6, sound waves are, see, sound waves can be longitudinal, it can be transverse, and this longitudinal transverse waves are basically two types of mechanical waves, so you know. So here the answer will be all the 3, option D. Okay, coming to number 7 now. Radar and sonar are based on which principle? So radar and sonar both works on reflection of light and sound respectively. So here the answer will be echo. Echo, we can basically, echo is about reflection of sound, but here if we analyze the options, then radar is completely based on light and sonar is completely based on sound. So echo means reflection of sound, but we can analyze this as reflection of light also, because both are waves, both are reflection. So most probable answer will be number 7A. Number 8, when a body freely falls towards earth, when a body freely falls towards earth, then its total energy is, what is its total energy? See, if the body falls towards the earth, definitely what happens is its mechanical energy remains conserved, and that is what total energy is meaning over here. So definitely the total energy will remain same, so this will be option C. There will be interconversion between potential and kinetic energy, however the total energy will not change. This is as per law of conservation of energy. Number 9. So in number 9 it is said, in case of negative work is only possible when the direction of the force and the displacement are in the opposite side. So that means here cos 180 degree is negative, so this is also done in class and also there is in your textbook. So definitely it will be option D, that is 180 degree. Next question, water stored in a dam possesses which kind of energy? Definitely they possess potential energy. Very easy question, very easy question. I will say not standard, right? Anybody can do this kind of questions just by seeing and studying a bit. Easy question. Number 11, 1 coulomb of charge is equivalent to the charge content in how many electrons? So this is a question of Q is equal to N into E. So you need to know Q is 1 coulomb and number of electrons is not known, we have to calculate. One electronic charge is 1.6 into 10 to the power minus 19. So N will be 1 by 1.6 into 10 to the power 19. So this will come out to be 6.25 into 10 to the power 18. So the option will be option D. Option will be option D. Now we'll go to question number 12. This is question number 12. So here if you see in question number 12, just give me a second. Yes, in question number 12 it is said, a wavelength of light, okay, the wavelength of the light in medium A is 600 nanometer. The wave enters medium B of refractive index 1.5. So here they have not said anything about the refractive index of medium A, so I'll take refractive index of medium B 1.5 as a relative refractive index with respect to medium A. Now to find out the wavelength in medium B, okay, so definitely we can see from here, if medium A is having a refractive index of 1 and medium B is having a refractive index of 1.5, medium B will be much more optically denser. So optically denser medium means what? Optically denser medium means it is going to have lesser wavelength. Lesser velocity means lesser wavelength. So first of all in this problem, if you have to find out the wavelength, first the wavelength is 600, so it has to be divided by 1.5, because in medium B the wavelength is going to come down, it is not going to increase, so it will be divided by 1.5, and if I do this calculation it will be 400. So if I see the options over here, it will be first it will be 2, then it will be 3, so here the option will be option B. Question number 12, the option will be option B. Okay, if there is any doubts please let me know, I am going to clarify it. Next question, if A and B of same mass, okay, there are two bodies of same mass, they climb the third floor of the same building in 3 minutes and 5 minutes respectively. They climb the third floor of the same building in 3 minutes and 5 minutes respectively. Okay, good. So definitely I can understand the power of A is much more because he is doing it in much lesser time. Okay, very good. So they have asked to find out the ratio of their powers. So power of A will be more. So here if you see the options, 1:1 incorrect, 3:5 incorrect, information insufficient. Let me see if there is any other option. Information is sufficient. 5:3 correct option. Option D. Coming to question number 4, if there is a block and tackle system with a convenient direction, okay, there's a convenient direction, has 3 movable pulley. They have 3 movable pulley. Very important question. Textbook theory oriented question. You have to study the textbook well to answer this one. Then what is its velocity ratio? Very good question. Convenient direction means it is pulled downwards, it is not pulled upwards. So it's just as normal as it gets, the ones we have done in book, except the one which is pulled upwards. Okay, so it's just pulled downwards. So it's a block and tackle system. Block and tackle system can have, if there are 3 movable pulleys, that means the system is like this, 3 pulleys in the bottom section and there are 3 pulleys in the top section. So if you see the top section, that can be having 3 pulleys or 4 pulleys. In block and tackle system, what happens is, if the top section has n number of pulleys, then the bottom section will have n or n minus 1 number of pulleys. So here it is already said that here it is having 3 pulleys, here it is having 3 pulleys in the bottom section. So in the top section it may have 3 or 4 pulleys, right? There are 2 options. So it can be 6 number of pulleys or 7 number of pulleys, and number of pulleys will be equal to the velocity ratio. So here the option will be number, okay, I'm really sorry about this, I think here the option will be number, which number will be the option? Okay, 6 or 7, so option C. Okay, so this is a little tricky question, but still it's a good question, right? It's better you face all the tricks now than to face it right away in the exams, right? Which lens has maximum power? Which lens has maximum power? See, jitna mota lens utna zyada power. This is known by everybody, right? However, you can do it by formulas also, not an issue, because focal length, it all depends on focal length. Power is equal to 1 by f, we know. So the one which has having the least focal length will have the highest power. The more curved the lens is, it is going to be a smaller sphere. Smaller sphere means lesser focal length, right? Smaller sphere means lesser focal length. So definitely here maximum power will be in case of Q. So it will be option B. So that ends our first part, that is the MCQ section. I will want each and everyone to pause at this point of time and check how much you have scored in the MCQ section, because this part starts the game here, where this is the opening partnership that you are going to do with your paper. So as better you play with this one, the total paper goes quite a easy way if you done well already with it. So I will suggest each and every one of you just to pause the video and see out of 15 how much marks you have scored, and then we'll proceed, Please pause the video. So I hope you have already checked the answers of MCQs and you have scored a fair amount of marks, I guess. So let us go for number 2 now. Okay, this is a very nice question, a conceptual question, based on whether you have again read the textbook well, or have you been very much clear with the concepts of refraction, that is in case of prisms, or not. So that is a question based on it. It's a very nice question, I will say. Okay, let's see. So it has been said that this prism which is asked over here, this prism is having an angle of 62 degree. This prism is having an angle of 62 degree. Okay, so angle of prism I will write down as 62 degree. Angle of prism is 62 degree. Okay, what is my next part? Calculate the value of x. This is the x. Okay, so that means I have to calculate angle of incidence at this point. So this curve basically denotes this part is angle of incidence, that is I, and this one, that is this one, is denoted by emergence. When you draw a horizontal line like this, so for a certain angle of deviation, the formula was I1 plus I2 minus A. Everybody is very much well conversant with this one. So here the deviation angle is 51 degree excuse me. I1 is 40 degree, correct? I1 is 40 degree, angle of incidence 40 degree, and I2 is not known to us, minus A is 62 degree. So from here I can easily get the value of I2. This will be 73 degree. So x is equal to 73 degree. Next it has been asked to calculate the angle of minimum deviation. Angle of minimum deviation will be at the bottom of this curve. So this will be 37 degrees. So the next answer, that is minimum deviation angle, is 37 degree, and the corresponding angle of incidence easily it can be got from the graph. Corresponding angle of incidence, that is in case of minimum deviation, it is 46 degree. It is 46 degree. This can be also achieved from the graph. So easy question. Only thing that you need to know is whether you have been able to comprehend that for an angle of deviation, the first part of the graph, that is the one that is coming down, should be the angle of incidence, will give you the angle of incidence on the x-axis, and the second part of the graph that is going up will give you the angle of emergence in the x-axis. The details of this concept, why this is happening, can be only explained in class. So this cannot be explained in this short session that we are arranging. So you may ask this in class. I will definitely explain this. During teaching I have already explained this one. Okay. Next question. So we have to find out what the next question is. So next question is simple question on moment of force. So I don't think I need to solve this. I'll just write down the answer. The answer will be 12 Newton meter. Answer will be 12 Newton meter. So you can check this whether you have got this answer or not. Very easy question. Okay. Next is background radiations. Define background radiations. Next question, that is question number 2C. Question number 2C is background radiations. What are background radiations, that you need to know. So this is again a very much theoretical questions. These are basically you need to go through the chapter of radioactivity. These are given in book. This is in syllabus. So background radiations are those radiations to which we all are actually exposed. We are exposed to all those radioactive radiations and we cannot really do away with it. This doesn't have any visible radioactive source. Like you have potassium 40 in your body that is giving some radioactive radiation. However, you cannot really avoid it, right? Like C14, carbon 14 is also there in my body, there in your body, and each and every plants there is carbon 14, based on which this carbon 14 dating is done. Someday maybe human being will be extinct, somebody else will find out that how much age was there. Maybe 200 million years ago there will exist one animal that is named as human being, or something else they may name us, and that is C14. So all this C14, K40, everything that is already present in our body is giving some radioactive radiation which we cannot really avoid, and those radiations are called background radiations. I hope the concept is clear. Okay, so it's a good question again. Background radiation, those who have not done radioactivity yet, they can go through this, or whatever I have said is enough for you to answer background radiation. If asked in ICSE examination, it will not be a problem. It's an easy question. What is the next question? Next question is, a nuclei loses 2 alpha particles. A nuclei loses 2 alpha particles. So what we'll do is I'll write the equation. So suppose this is Z, this is A. So it loses 2 alpha particles. So if it loses 2 alpha particles, that means X becomes A minus 8 and this becomes Z minus 4, 2 alpha particles. Question is that how can you make an isomer, say this is X dash, this is X double dash. So how can this X double dash be an isomer of X? So that means this has to have the atomic number Z. This has to have atomic number Z, correct? Agreed? Okay. So if this has to have an atomic number of Z, then what will be the transformation here between X dash and Z? So you have to find out what will be the transformation here between X dash and Z, and definitely you are going to find it out, right? Very easily you are going to find it out. So see, if you see this one, then it's a very simple question. From z minus 4, if you need to reach z, that means you have to add some plus 4 over here. And in beta radiations, only the atomic number increases. There is no change in mass number. So mass number will be minus 8 only, and in beta radiation it increases by 1. So we have to go for 4 beta radiations over here. That will be enough. Okay, 4 beta radiations will be enough for our cause. Okay, so that is done. I think question number 2 is done. You can check how much marks you have secured again. So our question number 3 now, it's again a question on radioactivity. It's a easy question. Alpha, beta and gamma radiations, we have to show the paths. So how will I show the paths of alpha, beta and gamma radiations over here? How will I show the path of alpha, beta and gamma radiations over here? So see, I'll show it over here only, it will be easier for me. So alpha radiations will go towards the negative part because alpha is a positive radiation, beta will reflect much faster because it's light, and gamma will go like this, straight, undeflected. Why the source S is kept in a thick lead walled container with a narrow opening? Because see, we are dealing with we are dealing with something that is radioactivity, right? So whatever there is source, it's a radioactive material, and definitely you, myself or anyone else, whoever is working with this experimental setup, will not want to get exposed to those radioactive radiations and get a life threatening disease or something like that. So what they are going to do, they are going to use certain material, certain enclosure which absorbs these radiations, and lead is such a material which can absorb these radioactive radiations. Who is going to absorb these radioactive radiations? Lead is going to absorb. So you can write here, to absorb radioactive radiations which can cause damage to our health. Correct? Very clear. Name the radiation unaffected by electrostatic field. Definitely the gamma radiation, it doesn't have any charge, it is unaffected. Which radiation is deflected the most? Beta radiations. Why it is deflected the most? Because it is light, it can be easily deflected, whereas the alpha radiations, being heavier, is not easily deflected. It is deflected, but if you see this graph, alpha radiations are deflected much later than beta radiation, right? So that's it, question number 3. I think question number 3 first part was pretty easy. Correct? Question number 3, the first part was pretty easy question. The next question was a question on half-life. Next question was a question on half-life. So we'll take question number 4 now. So this is our question on half-life. So this was a, you may say that we don't know all these things, but this was a basically logical question. Rather than if you just apply your mind and brain, you can solve this question. So what does half-life mean? From the question itself or from the name half-life, you can understand it is the time taken for a substance to reduce to its half. Okay, reduce to its half, that's it. That is what half-life is. So if there are 6 into 10 to the power 23 atoms, so how many atoms would be there present after 20 days? So it's not very tough question. So if there are n atoms, after 3.6 days it will be n by 2. After another 3.6 days it will be another n by 2, n by 4. After another 3.6 days, so already we are going 3 into 3. Okay, it will be n by 8. Next, another 3.6 days, it will be n by 16. Another 3.6 days, it will be n by 32. So let us see how much time we have already spent. 7.2, so 10.8, 13.8, 6, 14.4, 6, 15.15, 18. So another 3.6 means approximately 21 days. So this will become n by 64. So you can write approximately it is 6.02 10 to the power 23 divided by 64. Tough question. So yes, in this question we are going to give you bonus marks. So those who have attempted it, you are going to get full marks. Okay, so don't worry about this. Next question is, three differences between alpha, beta and gamma particles. I'll say please refer text for this. There is no point discussing this, right? You can refer text and get this very easily. Two bodies have m1 and m2. Okay, the masses is m1 and m2. They have equal kinetic energy. Okay, find the ratio between their momentum. So P is equal to rho to mk. So I have to find out the ratio of the momentum. P2 by P1, I can go forward with it. This will be 2 m2k, because they have equal kinetic energy. 2 m1k, equal kinetic energy cuts down to 2. Very easy question. See, very easy question, just this formula and you can do everything. In ICSE examination I'll say you this formula is very important. Okay, so you guys must go with it. Okay, this is many questions have been asked with this formula, because people tend to not do this formula very well, that's why. State the energy changes. DC motor, AC generator. In DC motor, energy changes from electrical to DC motor, it changes from electrical to mechanical, and in AC generator it changes from mechanical to electrical. Okay, that's what it is, nothing else. We'll go for the next question. So we have covered of section 1. Section 1 is done. Everything so far so good. Okay, so we'll come to section 2. First question now. See, there are many questions which are theoretical and you might be able to do it just by going through the book. Maybe you have missed it because you have not studied it well. So definitely in next examination you are going to ace it, I know that, and I am very confident about it. Not only I know that, I am very confident about it that you are going to ace it in next exam. Chalo. Okay, first is this one, calculate the mass of the ruler. So just you have to apply the moment of force concepts, nothing else. So this is very simple question, very simple question this is. So I hope each and everyone have done this one. Answer is 62.5 gf. Its answer is 62.5 gf. Just anti-clockwise moment is equal to clockwise moment, as simple as that. Pretty easy question. Should I solve it? Okay, I'll do it. 25, see here it is 25. 50, 25 into 50, weight will act at 50 centimeter mark, is equal to 20 into W. So this will be, W will be 62.5. Done. When a ray of light passes from air to glass, for what angle of incidence the ray will not be deviated? Again a very simple question, 0 degree. What happens to this one? Nice question, very nice question. So why does a ray doesn't deviate if it passes through optical center or it deviates? So actually the ray deviates. So here by diagram you need to show that how the ray deviates like this and then it goes like this. So it is kind of a glass slab where there is a lateral displacement occurring. So if the lens is very thin, then this lateral displacement will be negligible and there will be no deviation which we are assuming in case of thin lens. But in case of thick lens, you have to show this diagram. Please everyone, this is a very nice question. Again, just checks whether you have understood it or just you have remembered light ray going through optical center does not deviate. Please do not learn this by heart. try to understand. It is only applicable for thin lens. For thick lens it is absolute rubbish. For thick lens it does deviate. It does deviate for thick lens. If I wear a very thick spectacle, then definitely the light will not come straight through. It will have some lateral displacement coming towards my eye. Okay. Oh, superbly easy question. Superbly easy question. Mu is equal to real depth by apparent depth. Mu is equal to real depth by apparent depth. Mu is equal to 17 by mu is equal to 17 by 17 minus 4.75. Answer will be approximately 1.39. This section was very easy, I guess. In a thick mirror, second image is brightest. Why? Due to first strong reflection. So this section was very easy, I'll say. This section was very easy. So next we have ray diagrams, I think. Okay, we have again optics. Too much optics in this paper. Makes it easy, right? At least in the second section. Too much optics. So it is a converging lens, convex lens. Yes, you have to draw this ray diagram. You need to draw this ray diagram. Complete this ray diagram. Formation of image of object AB. So you need to take this, draw arrows and complete this ray diagram. Okay, like this. You need to complete this ray diagram. So I hope everybody will be able to complete this ray diagram well, because this is not much tough. So you can understand this is the focus. So if this is f2, this must be f1. So the object is in between focus and the optical center. So definitely the image will be a virtual image. So you need to retrace back and draw the diagram. The last diagram of convex lens from your textbook needs to be drawn, and it will be a definitely a virtual image, enlarged image. So I have drawn a very beautiful looking diagram according to me. So please draw it nicely, give all the arrows so that you can get the full marks in this one. Okay. And where it is used in case of reading lens. Okay, magnifying glass, you can use this one, this principle. Please write down, magnifying glass, reading lens. Next is copy and complete the diagrams which emerges. So I have already done this with my hand. So I'll give you the total diagrams which I have drawn, so that you can understand how it is done. There are 3 ray diagrams given. So I hope everything is visible. So these are the 3 ray diagrams. So each and everything depends on geometry. As you know, I don't know how much I know geometry, but definitely I love geometry. That's true. Okay. So, and geometry is very important part in physics, and light, definitely we understand that. So this is the diagram. So you can pause the video a bit and you can copy this one. Okay. Have you completed? So we are going ahead with our next question. Going ahead with our next question. So this is our next question. Which property of ultrasonic light is used in radar? So this is basically we are using the property that is high directivity and high energy. Okay. Calculate the refractive index of the liquid with respect to air. So this will be sine 60 degree divided by sine 45 degree. So this is the angle of incidence, 60 degree. So this will be root 3 by 2, and this will be sine 45 is 1 by root 2. So root 3 by 2 into root 2. So this can be cancelled out, root 3 by 2. So you can just have to do some mathematical jugglery and you will be able to find out the answer. The answer will be approximately 1.225. Text based question, easy questions, and I hope each and every one of you will be able to do this kind of stuff. Coming to question number 6. Okay, draw distance displacement curve of two waves. Okay, distance displacement curve of two waves A and B such that amplitude of wave A is 3 times that of wave B. Okay, very important, easy question I think. So they have not said anything about the frequency. So here suppose it is 1, here it is 2, or here it is 3. So one wave is having amplitude of 3, I'll go for 3. So please draw this in a proper fashion, make a good graph. Okay. And the other one is having much lesser amplitude, that is this one. Okay. Okay. So this is A and this is B. Okay, A is 3 times. So this is A, I think. धोखा हो गया 2 3 okay. So this is A and I'm drawing B now. In proper way you have to draw this. So this is a simple one. Now what is the example of force vibration? Giving a slap to your face will be an example of force vibration, or slapping myself is an example of force vibration. I hope you like that. You can slap yourself too. Why frequency of light doesn't change on refraction? See, as velocity increases, lambda also increases proportionately, and frequency is basically number of waves per second. Number of waves that is passing through one medium has to pass through other medium also in same frequency. If 5 number of waves passes through one medium per second, those 5 number of waves has to pass through another medium also in similar amount of time, that is 1 second. That cannot change. So whenever this velocity decreases, this lambda decreases and this frequency remains constant. Frequency is number of waves per unit second, that cannot change. Frequency is number of waves per unit second, and that cannot change. What can change? Change can be like in case of lambda, lambda can change definitely with velocity proportionately, that is in straight line. Sometimes I may draw a graph also like this. If you draw a graph velocity versus lambda, if velocity changes, lambda will change with at straight line. That means the constant slope theta remains constant, tan theta is equal to f, that is frequency, so it doesn't change. So here the explanation should be like that: frequency is number of waves per second, and number of waves must pass through from one medium to another with same frequency, and hence lambda changes proportionately with velocity, however frequency remains constant. Okay guys, okay, now the question on resistance. So have you done this one, resistance question? Oh, before there is a question. John fires a gun towards a hill. So this is pretty easy question, I think, not much tough. Easy question. John fires a gun. So I'll solve this. Can I rub this? Okay. So John fires a gun towards the hill, hears the echo after 5 seconds. Okay. So here is the hill, here is the hill, here from he fires the gun and the gunshot gives a echo and hears it after 5 seconds. Okay. So here I can say if this distance is x, if this distance is x by 5, that will be equal to the velocity of sound, and then he moves 320 meters back. Okay. So this is 320. Again he fires another time. So this becomes x plus 320, right? Oh, towards the hill. He goes towards the hill. So this is V. Here he goes, John, and this becomes x minus 320. So 2 into x minus 320 divided by 3 seconds is equal to V. So from here you can easily solve for V, and V will come out to be 320 meter per second. If I rub this one, and join this, then also it is same. So all these 4 potentials, that is 1 by 4 plus 1 by 4 plus 1 by 3 plus 1 by 6 are in parallel. Has to be. So these are basically joint circuit. So it is like this. Okay. And then again it goes like this. Very nice question. A, B. This one you can write as C or D, doesn't matter. 1 by R. So here you have to do the parallel one. So here it is, that is 1. So this part is 1. Now we have to do this part. So this part is 2, 2, 40 and 10. So 1 by 2 plus 1 by 2, 1 by 40 plus 1 by 10. So this part is like plus 50 by 400, that is 8 by 9, that is 1 17 by 9, this one, correct? 50 by 400, no, not 8 by 9, what I am doing. Fifty by 408, that is 9 by 8, so it will be 8 by 9, and hence these two again are in series. So this is 8 by 9, this is 1. So the total equivalent resistance for this circuit will be 1 8 by 9. Okay guys, nice question I think. So we need to apply some brain over here. Same potential in this, in between these 2 points. So all these are parallel. That is the way we need to do it. Good problem. Next question, question number 7. So already going very fast here, right? Question number 7. I'm not going to spend much time for you guys, also going to do fast. So this is a easy question. I will just give you the answers over here. So in case of this one, the answer will be 5 by 4 ampere. Okay, if K is open, K is, I think this will be 5 by 4 ampere. Okay, and this will be, K is closed, closed means switch is on, so that will be 15 by 4 ampere. Okay, now you can have a check on this one. Let's see this one, 10 volt. Okay, 10 by 8, key is open, 10 by 8, 5 by 4, correct. Key is closed, will be 4 and 8, we have to go for parallel connection, that is the resistance will come down, 1 by 4 plus 1 by 8 is equal to 1 by R. So resistance will be, if you calculate this, it will come out to be 8 by 3. And then if you put this 10 by 8 by 3, we are going to get this. Okay, Mr. Pinto's flat, 6 bulbs of 100 watt each. So I have already solved this one. This will come out to be 766.5 rupees. This one, this is an easy question. I am not solving it in detail. If you are having any problem, I will definitely do that. Next is this one. So this is from magnetism. So the first question is, what will you observe when the magnet is dropped into the coil? The galvanometer will deflect. Definitely that's what I am going to observe. The rate of deflection increases. Yes, the rate of deflection will increase when the number of turns in the coil is increased. Okay, so very fast it is going to deflect. And what will be the direction of the current flowing through the coil? Okay, when magnet is dropped in, clockwise or anti-clockwise? So see, here when the magnet is dropped in, this is going to have a north pole over here. So I am just considering when the magnet is getting dropped. I am not considering the space when the magnet is already dropped. Okay, just getting dropped, it is going to induce a north pole over here, it is going to induce a south pole over here. North pole means anti-clockwise direction current. So this is the way the current is going to flow. I'll draw a diagram and show it. I'll draw a diagram and show this one. This is the direction at which it is going to flow. Okay, next question is, state the law which explains this observation. Lenz's law. Lenz's law, law of conservation of energy. Lenz's law, you need to write down Lenz's law. That's it. Again, a very simple question on electromagnetism. Very simple question. Okay. Question number 8, heat and calorimetry. Heat and calorimetry questions. Okay. So this one, the first one, the answer will be 8A. The first answer will be 186480 joule. Body of mass 2 kg, another body of mass 4 kg, kept in sunshine for some time. If the rise in temperature is equal for both the sides, okay, so that means delta T of 2 kg and delta T of 4 kg is same. Okay, no problem. So 2 into C of A delta T is equal to 4 into C of B into delta T. Find the ratio of the specific heat capacity. So I'll consider they have absorbed the same amount of heat over here. del T cancels out, so Ca by Cb will be 4 by 2, that is 2:1. How does pressure and impurity affect the boiling point and melting point? So if you consider water, then pressure increases the boiling point, impurity also increases the boiling point. And in case of melting point, if impurity increases, melting point decreases, and if pressure increases, melting point decreases. So it is just the opposite. Okay, elevation of boiling point, depression of freezing point. Boiling point will increase, melting point will decrease. Melting point will decrease, boiling point will always increase in case of water. Okay. Our last question, question number 9. What are the factors on which characteristic of musical note depends? Okay, intensity will depend on amplitude. So here intensity will depend on amplitude, and timbre will depend on waveform. Okay. How does a trawler man catch fish in deep water? Well, he uses ultrasonic, he uses the principle of echo depth sounding, wherein he uses a ultrasonic emitter. Okay, this is a suppose a boat, ultrasonic emitter is there, it emits ultraviolet rays to see the amount of fishes that are there, and based on the amount of or number of echoes he gets, which gets absorbed in ultrasonic receiver, he can understand the amount of fish that is there, and accordingly he spreads his net in the place where he gets lots and lots of echo. That means lots and lots of fish are there. So here you have to write, he uses the principle of echo depth sounding to find out where there are many fishes, and you just give a small diagram like this, and accordingly he fishes. What are the factors on which the resistance of conductor depends? So this one I'll say you can go through the book, this is pretty factual stuff, so please refer text for this. Material used for electric fuse, solder, copper or aluminium, tungsten, nichrome. 20 kg of water, 15 degree to 15 degree, 50 degree, you have to use 4.2. So this is again an easy problem. What is efficiency? I'll hit that one. First of all, you will get when you calculate the power. Excuse me. Calculate the power. So here if you see there is no time given, so you will consider 1 second. So power will come 2800 final power. So calculated power will be calculated power whatever you get divided by 0.9, because it's a 90% heater efficiency. So that means if you give 100 kilowatt, you are going to get 90 kilowatt. So whatever is required, that is just 90%. Okay. So power to that equipment you have to give 100 now. So you have to divide by 0.9, and by doing that you are going to get this answer. So with that I think we finish our total discussion of first physics mock. Challenging, little bit lengthy I think. Some of the questions were challenging, most of the questions were easy I guess. So a good paper, lot of brainstorming needs to be done, and I think we have done it today, and we will be continuing to do so. So don't worry about anything that has happened, or even if you have given a very good exam, don't be complacent. Go ahead with more intensity, study more and more, because revision is not a very easy job, specifically for those who have already completed the syllabus, because people like us don't like to revise. Completed, everything is complete, So what I'll do, I'll study something else. Everything is complete. But however, from examination point of view, revision is very important. Even if you have completed, now the challenge for you is to give as many mock tests as possible. Wherever you give as many mock tests as possible, so that you can score much high marks in these mock tests. So as you give lot of mock tests, like 8 mock tests, 9 mock tests per subjects, maybe, if you can really give in your home also. Take some previous year papers and give. Don't take this, I'll not name anybody, but don't take all this stuffs, this publisher, that publisher, not required. This is just publicity, marketing stuff. Don't do that. Do previous year question papers, do specimen papers, take one paper, solve it continuously. By not seeing the book, you are going to do well. Okay, because market publishers, they don't give you standard papers. They don't spend much time. They have to release the books every year. Most of the questions are from here and there only, and many a times in the sake of for the sake of this releasing early, they make mistakes in their solutions, and they sometimes they give a paper which is very much higher, above standard, and in some of the papers I have seen, and in some cases, in most cases I have seen, in case of physics specifically, the papers are substandard with respect to ICSE examinations. ICSE examinations papers are much better than the ones that are available in market. Okay, so do all those things. I'll say do just previous year paper, that is more than enough. Invest time in your concepts, job will be done. With that note, we are going to close today's session, and we are going to give a great examination in our upcoming mock test. Correct? So with that, thumbs up, good night.